Hello, this is my video about this Tesla coil I built. As you can see, I'm mainly using it for lighting up gases and other experiments in my lab. And it looks cool. Yeah, so in my projects I like to combine old tech with new tech. As you can see here, there's like old Soviet high power switch, old Soviet vacuum tube, old Soviet capacitors, combined with 3D printed parts and modern parts, and all together make something useful. Also, I like to shake up the conventions and do things differently, so I hope you pick up some new approaches from this video. Let's take a closer look on the tube. As you can see, there are markings C3 and A. It means grid 3 and anode. Pretty cool. It's very big power amplifier or something, Soviet vacuum tube. Pretty cool artifact, I would say. That's how it looks in X-ray. So you can see the outer layer is graphite, so it's like transparent. Yeah, moving on, I made this special connector to it, which didn't work very well, as you can see, because it's kinda melted. That's how it's look inside. So inside there is a copper wire. I added those two additional wires to make it more robust and not overheat. Here you can see the bed for the tube, which has fan and LED lights. Yeah, like that, because the tube runs pretty hot. The normal operational temperature is 300 degrees, so to keep everything cool there is a fan that blows upwards and keeping stuff from melting. Yeah. There's connector. Yeah, that's how it works. Nothing special. Alright, moving on. Here you can see the blue one is the main resonant capacitor, the gray ones are the filtering capacitors, and this is the cool part. This is the filament voltage regulating circuit, so it's that green knob over there. I can adjust the brightness of the tube and also its power, so I can use lower or higher power settings adjustable, and it's as easy as that. You can just do it in parallel. The other thing is those thermistors. Those used as passive component for slow start of the filament. So to fully conduct they need to heat up to about 100 degrees, as you can see. And it takes about 5 seconds though, so the current rises like linearly for 5 seconds. And this circuit passively makes it to slow start. On the back you can see the power outlet with grounding wire and two microwave oven capacitors. Here you can see how secondary is grounded. You can see parts of feedback coil. Yeah, grounding goes to outlet actually. And here you can see a radio switch which operates that solid state relay, so I can remotely operate whole thing safely. Alright, this is the scheme. It starts over here with power outlet, grounded of course. It goes to microwave oven transformer, alright. Then through microwave oven capacitor, two of them, some 4 diodes, 4 high voltage caps, goes to main resonance part here with a ref rated cap and primary coil. Then it goes to tube anode. Then it's regulated by feedback coil, which is connected directly to grid 1 and 3 and connected to grid 2 with 1K resistor for some reason. Okay. Then tube has filament, which is powered through thermistor by that 12 volt 15 amps power supply. And middle part of it is connected to bottom rail and all the way to microwave oven transformer. Also there is a radio switch that I use to remotely control it, and there is a solid state relay that turns transformer on and off. Also there is filament voltage adjustment thingy, the knob that I can turn to adjust voltage. And yeah, and this is the secondary coil, and from there sparks are going off, and it's grounded from the bottom. That's it. Alright, moving on to 3D modeling. Here you can see the early prototype and the final version. As you can see, they kind of different sizes, because the final version is approximately 2 times bigger. That's how development works, right? And also there's another interesting thing. There is a feedback coil inside that you cannot see from outside, so I'm showing it here. Moving on. Yeah, instead of varnish wire, I'm using 32 gauge standard silicon coated wire and this custom keyboard controlled servo. Don't worry about it, I also made it. But winding process was pretty easy with it. As you can see, no varnish, no coating required. This is my secondary. That's how it looks like. Yeah, those are the early prototypes. But for the top load, there is 3D printed toroid with aluminum tape on it. But yeah, and screw. I put a screw on it to connect it to the secondary, because as you can see, soldering doesn't work. Here I'm showing that these charges are relatively safe to touch. It's you can feel it, but it doesn't hurt much. So yeah, don't recommend it though. Here are some mistakes. The main one was, as you can see, there is like a paper insulator between primary and secondary, so I didn't leave enough air gap between primary and secondary. That was a mistake. No matter what I did, didn't work, except when I put enough distance between them. At least 5 centimeters or 1 inch will resolve the issue. Look how much bruising the secondary took, but it still works. I didn't rewound it. And yeah, this is the white secondary. So let's talk about wires. This is the normal wire and high voltage wire. As you can see, normal wire has a lot of bruisings because at these voltages and frequencies, normal insulation doesn't work at all. Yeah, so I recommend using high voltage wires. And here I'm gonna demonstrate what the difference is. Look, this is the normal wire, and you can clearly see how energy goes through insulation without any resistance even. Like you can see it with the naked eye. And on high voltage wires, nothing's happening, so those are pretty robust. I recommend those. They are rated for 50 kilovolts and they works great. Although I wrapped them in another layer of silicone just in case, you know. Yeah, that's the part about wires. Now about tuning. I'm using external capacitor, the vacuum variable capacitor one. Few people knows that those exist. Yeah, but I do, and I use it. So look, if I connect one end of it to common rail and the other end to anode, basically in parallel to main resonant capacitor, yeah, the blue one, then I can adjust in the knob, can tune it properly and get the maximum power, which I believe this is the maximum power output I can get from one microwave oven transformer setup. The sparks are about 40 centimeters long. But the downside is that the system cannot run continuously in this mode. It will overheat. As you can see, the tube is glowing red right now. Yeah. So usually I'm not using the external capacitor and running it slightly out of tune, but it can run indefinitely in this low power mode. Yeah. That's the same shot, but in the without light, and you can see some weird patterns when sparks are hitting the wall. I didn't see other people doing that, so I'm including this shot. Alright, enough of the build, let's go to experiments. So here are some early experiments with gases. This vessel is filled with low pressure argon, and we can observe some interesting behavior, you know. Oh yeah, still overheating. Well, this was the early build, don't worry about it. Yeah, those tubes are pretty robust, they're Soviet made, they can handle some overloading. Yeah. See, it was glowing red hot, and then you can run it on again, it will be fine. It can take some abuse. Here I'm testing a vacuumation of a bottle for a next project. Looks pretty cool. Here is another ancient artifact, which is a xenon vessel. Well, it's a projector lamp or something, but for me it's xenon vessel for the next project, don't worry about it. And that's how it looks from up close. Here is a low pressure argon in the flask. Also interesting effect. So you can test different pressures and gas mixtures. Yeah, here I'm cooking a sandwich on the Tesla coil. Actually, it worked pretty well. It tastes like it was cooked on a bonfire. Smoky. There is another experiment for my next projects. You can see the low pressure gas glowing inside the opened up vacuum tube, as it should, lavender color. And here is Nixie tube. Fascinating how it can glow in bare hands within that electric field that Tesla coil produces. Well, that's the classic experiment. The mercury vapor tube around Tesla coil always glows. Yeah. Here is the smaller one. And with this one, I want to show that the electric field around Tesla coil is about 1 meter radius. I mean diameter or radius, whatever. 1 meter sphere. Even at low power setting. So pretty much space to play around. And here is a small xenon field tube. Alright, this is the end of the video. I hope you learned something new or useful, or I don't know, pick up something for yourself. And yeah, thank you for watching and see you around. Yeah, feel free to leave comments and likes and support my channel. See you around.